Okay, so now let's comment this out and try to compute some quantities. So what is the skin friction coefficient of the boundary layer? It's equal to tau divided by half of rho u square, right? So rho is 1 here, okay? And what is UE? UE is simply UP end, right? So at the outside of the boundary layer. So CF is equal to tau divided by half of UE square. And what is tau here in the unit of Y plus and U plus? 1. That's right, because that's tau is simply U star squared, right? U star is 1 in this unit. So tau is always equal to 1. Okay, so here we computed a CF. So if we redo this, we have a CF that is equal to 0.001. So we can keep doing this. Oh yeah, not only we have a CF, but we should also be able to compute, for example, RE theta. So in order for me to compute RE theta, I need what? I need UE times theta divided by nu, which again on this unit, nu is equal to 1. That's right. Okay, so in order for me to have this, I need not only UE but also theta. How do we integrate theta? Theta is equal to an integral, which in this is a sum of 1 minus, let's say, u divided by UE, right? Integrated with dy. So let's see what is dy, what is u. So u is basically, okay, so let me actually say this. U is equal to up 2 to end plus up 1 to end minus 1. It's half of that. So I'm averaging the velocity within each interval, right? So I'm trying to use trapezoidal rule to do the integration. I will non-dimensionalize by UE just over here. So I just have a sum of 1 minus u times dy. And dy in this case is yp of 2 to end minus yp of 1 to end minus 1, right? Okay, so now I get theta. So let's run this again. Theta in this case is it's about 17,000. All right. So this is for a total thickness of 100,000. So this is 100,000 is the 99% thickness.
Is it theta squared or 1 minus? Oh, or to multiply by u.
Oh, sorry. Yes, I have to multiply by u. That's right.
That's delta, right?
Yeah, what I just computed was delta. So let's compute delta because we need to compute the shape factor anyway. So let's do that. I have a delta, which what I would just said was delta, and theta was a little bit lower than that. Right, it's about 12,000. And the shape factor, of course, h is equal to delta divided by theta is 1.38. So let's compute that.
How is delta different from the d that we defined?
How is delta different from
The d that we specified.
Oh, because delta is the displacement thickness, where d is the total thickness of the boundary layer. Usually in experiments, it's defined as the velocity, the mean velocity reaching 99% of the free stream. So here we just we ignore the 1% and actually define this UE to be just the 99%. If you want to be more rigorous, we should say UE equal to this divided by 0.99, something like that. All right. So if you rerun this, my H it's barely changed. Okay. So let's see what we computed. We computed three non-dimensional numbers, CF, RE theta, and H.